Guys, this is proof number 2 of Euclidean geometry, Krazifizix, and here we're looking at proving angle at the center, and this is part 1 of it. There are 3 variations I'd like you to be aware of. So this is part 1. We're going to run through as quickly as possible, but before we write, let us try to understand so that we don't need to cram. So the first thing with Euclidean is it sometimes needs construction. So I will construct a line from C passing through O. Usually I like taking it and putting it right on the circumference. So let's call it P. And if I construct that, it means I am already demarcating angles. So you would see that I have demarcated this. We can call it O1 and call this O2. Very important. Now I have also demarcated angle C. So I'll call it 1 and 2. To make life easy, I love to do this. I love to use X and Y's. So let me call this angle X and I'll call this angle Y. It just makes it easy. Now let's quickly look at the dynamics of the proof before we start doing write-ups. Do you notice that now I have OA, which is a radius. I also have OD, which is a radius. That gives me a triangle called an isosceles triangle. We did that when we're in grade 7. And one of the properties is that we have 2 angles equal, angles that are opposite equal side. What does it mean? It means if A is X, angle C1 also would be X. Which means if B is Y, angle C2 also will be Y. Okay, let's see where this will lead us to. So gradually, we go through the proof. We start by writing what we did in terms of construction. So we say construct CT, construct line, it was COP. Okay, cop line. Then we said let angle A be X. We need that. Let angle A, it's just to make it easy on the eyes, be X. So angle A is equal to angle C1, which is equal to what? X. What's your reason? Angles that are opposite equal sides. Which sides are we talking about? We're talking about radii. Even if we don't put the word radii there, we're still okay. That's the first thing. Now, if we look at that, I want us to quickly go back and study angle O1. Look at this angle O1. It's the outside angle from this triangle, and it's called an exterior. And one of the rules we know is the exterior angle is equal to sum of opposite, which is A and C. Oh, by the way, A is X and C1 is also X. So X plus X, this is 2X. Great. So let's go there. So angle O1 will be equal to angle A plus angle what? My plus looks like a times. Plus angle what? C1, which is X plus X, 2X. Exterior angle is equal to sum of opposite interior what? Angles. Lovely. Now we don't need to do all of this again on the right hand side. It's a copy and paste because this is exactly the same. So if this is X and this is X, this is 2X, Y, what do you think that would be? That would be 2Y. So we don't need to do that. We're just going to say similarly, because it's the same thing. Similarly, angle O2 will be equal to what? Angle B plus angle C2. And we say that is 2Y. Now let's look at something quickly. What is O1, angle O1 plus angle O2? From what we have, don't you see? It's 2X and angle O2 is 2Y. Oh, what is common? Do you notice it is 2X plus Y? And now let's go rename all our angles. What is O1 plus O2? Look at it. O1 and O2. O1 and O2. Oh, that is angle AOB. Lovely. Okay. And we said X plus Y. What is X? C1. What is Y? C2. Oh, if we were to name that angle, we call it ACB. Don't forget AOB, ACB. Beautiful. So we now making our conclusion. This angle O1 and O2 that we said is now what? Angle AOB, right? Okay, let me call this one that first. This is where we are. Now, what is this entire thing? It's angle AOB, which is equal to 2. What is x plus y? Angle AC and B. We are done with the proof. Look at it. AOB equals to 2ACB. And that's it. That is 6 marks for you in an exam. All right. You can download our Krazifizix study app to get more of these proofs. Remember, this is proof 1 of 1 to 3 when it comes to angle at the center.